Number 2. Earth Science. Listen and take notes on the important information in the lecture.
Today, I'll begin with the basics about minerals. It's important that you supplement this information by reading Chapter 3 in your textbook because I'm sticking only to the bare bones here. All right. It's essential to remember that both chemical composition and crystal structure together define a mineral. Some students find that surprising. They think that crystals are pure, just one element. That may be true for some crystals, but not all. Minerals range in composition from pure elements and simple salts to very complex silicates with thousands of known forms. So, to define a mineral, we have to figure its composition. What all is in it? Now, here is a useful tip that may save you a point or two on the next exam. Organic compounds are usually excluded from the category mineral. Got that? If it's organic, don't classify it as a mineral. In fact, there are 5 main criteria for calling something a mineral. Let's go through those criteria. First of all, it must be in a solid state, not liquid, gas, or plasma. Minerals are solid. Second, it must be naturally occurring. In other words, it can't be man-made. Third, it has to be inorganic. Like I said, if it's organic, it's not a mineral. We're on number 4 now. Fourth, for something to be a mineral, it needs to have a fixed composition, which means the chemical composition is the same everywhere it is found and every time it is found. Mineral X found in my backyard is going to have the same composition as mineral X found in Australia. Finally, our 5th criterion is that a mineral must be either an element or a compound, so it cannot be a mixture of a chemical compound and an element. Don't worry if that last one seems a bit vague at the moment. We'll talk a lot more about that over the next couple of classes. Sometimes we get certain cases that satisfy all but one criterion. That's close, but not a mineral. These things are usually classified as mineraloids. Pearls would be a good example. Pearls are solid. They occur naturally. They have a fixed composition, and they're a compound. The only criterion they don't meet is the inorganic test. Pearls are actually a mixture of organic and inorganic substances. So, because they have that extra organic stuff mixed in, we can't classify them as minerals. Pearls should be called mineraloids. Now, here's another interesting case. 2 or more minerals may have the same chemical composition, but differ in crystal structure. These are known as polymorphs. A good example of a polymorph pair is pyrite and marcasite, which are both iron sulfide. Let's create a simple analogy to help you grasp that concept in case you're confused. Let's say Michelangelo has one large piece of marble. He splits it in 2. One piece he carves into the shape of a horse, and the other piece into the shape of a woman. They are exactly the same in chemical composition, but nobody would really claim they're the same after he's finished. Think of pyrite and marcasite as 2 of nature's sculptures, both made of iron sulfide. All right, let's see if you've been listening. Here's my question. How about frozen H2O, or ice in layman's terms? Is it a mineral? Anybody? Yes, Sam.
Well, I'm not positive about this, but in liquid state, it's just a chemical compound, right? But as ice, it becomes a mineral.
We've got the 5 criteria for minerals, right? Tell me about each one in terms of ice, and we can check.
Okay. Ice is a solid with crystalline structure, and it's not a human-made substance. Ice isn't alive and never has been. It's, how did you put it? Exactly the same everywhere you find it and every time you find it, or whatever. It's a pure compound, although it might have other elements suspended in it. Did I cover everything?
Well done, Sam. I'm glad somebody was listening. You're absolutely right. Ice is a mineral.
kind of strange, though. Before this class, I never would have thought of ice as a mineral.
I agree that it's odd to think of it as a mineral. That's because most of the minerals around us seem like metals or rocks. Most people forget that minerals come in many states of matter and forms. That's why we have those 5 criteria for determining whether or not a substance is a mineral. Also, we need to keep in mind that both chemical composition and crystal structure together define a mineral. Okay, so now we can identify minerals. But what can we do with them?